Page 15. Condyle's a plus, sticks out. Smooth and rounded. Crest sticks out. Facet is a 0, it's flat. Fissure is a minus, it's a long cleft. Foramen is a minus, it's a hole that goes all the way through. Fossa is a minus. Fossa means cup, so it's a cup-like depression. It sticks in. Head is a plus. Line is a plus. A line is a mini crest. Meatus is a minus. It's a hole, but it doesn't go all the way through. A canal with only one entrance. Process is a plus. Ramus is a plus. Spine is a plus. It sticks out, it comes to a point. Trochanter, I would put 2 pluses. It's huge, and you only have 2, and they're both on the femur. But they're huge, they stick out hugely. Okay. Trochlea, that is the plus minus. It sticks out, it's actually a condyle, but then there's a groove in it. Tubercle and tuberosity are pluses. They both stick out. Now if you go back to page 7, and just go down the list of structures, and you're going to see these words. Tubercle, fossa, process, spine, fossa, 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 tubercle, tubercle. Head, tuberosity, fossa, fossa. Trochlea, that's the plus minus. Everybody see why I went to the terms first?
Yes.
You're going to see those words again and again and again. Everybody got it? Okay. Now let's go to page 13 and 14. That's going to be this 5 extra credit stations. They're going to be over there on that counter. The first 4 are going to be based off of pages 13 and 14. So that's 8 out of the 10 extra credit points. Every station has 2 questions, A and B. Everybody remember that? Just back, there's 5, A and B, 10 points. First 4 of these, articulations. Articulations is same as joints. And these are the functional classifications of joints. And there are 3 major classifications, and they are capitalized. You don't have to write them out capitalized, but this helps students to keep this straight. They're based on functional classifications based on how much it moves. Synarthroses do not move. Amphiarthroses move a little bit. Diarthroses move a lot. And remember, we talked about diarthroses today in lecture. That's where we find synovial membranes. You guys remember that?
Yeah.
In fact, if you read it, they're freely movable joints enclosed with synovial capsules. And inside the capsule is synovial membranes, one of the 4 body membranes. Diarthroses. Everybody got it? Now, underneath those major classifications are the minor subtypes, and they are in small case letters. Does everybody see that? Okay? Now, if you look over there on page 14, it's just a picture version of this. Those 4 stations are going to have pictures like on page 14, except it's blank with just a couple of lines on it. Everybody got it? Actually, each station is going to only have 1 line on it because I'm only going to be talking about 1 joint on that figure. And the A question is going to be what is the major classification, which would be one of the capitalized words. And the B question is what is the subtype, which is going to be one of the small case words. I'm going to do that 4 times. That's why it's 8 points of the 10 extra credit points on lab exam 1. Any questions about that? Is that straightforward?
Yes.
So just study the figure on page 14 because that's what I'm going to use, is the figure on page 14 with 1 line. And the A question is what is the capitalized word? B question is what is the small case word? Everybody got it? Any questions on that? Now let's move to page 7. Appendicular skeleton. What I tell students is that you do not want to lose sight of the forest for the trees. What that means is don't get so lost in the details, you forget the whole. So while I was a student studying the skeleton, and all the little bumps and depressions and holes in the skeleton, I would always have an articulated skeleton nearby, and if you can't have an articulated skeleton nearby, then I would have a picture from your textbook of an articulated skeleton. I'll explain more why later. But it really helps to see how things fit. For example, in some of the details we got to cover today, some of the names make sense because of how it articulates. The trochlea on the humerus articulates with the trochlear notch. The acromial end of the clavicle we're going to just talk about articulates with the acromion. All those are on your page 7. Okay? Some of the names make sense. Make them make sense because not all of them do. So the ones that do make sense, utilize them. Okay? Because you're going to have plenty that don't make sense. They only make sense in the articulated skeleton. Now, the skeleton, we're going to divide in half between this week's lab and next week's lab. Next week, we're going to cover the axial skeleton, which is like the axis on your car. The axle. It's the center. And the wheels turn around it. Everybody got it? This week, we're covering the wheel that turns around the axis. The axial skeleton is skull, vertebral columns, and ribs. That's it. What we're covering today is the pectoral girdle and the upper extremity, the pelvic girdle, and the lower extremity. Next week we're covering the axis, axial skeleton. Everybody got it? All right. So since these are appendages, they're all paired. You got a left appendage and a right appendage, upper and lower. Everybody can see how they're paired? All paired. Then it says right there on page 7, capitalized and underlined and emboldened, no right from left. That's what I wrote on the whiteboard. You need to know right from left. Everybody see that? Here's what you want to write next to that. In order to determine right from left, you need to identify structures on 2 different planes. You need to identify structures on 2 different planes. All right, what is a plane? Medial lateral is the same plane. Posterior and anterior is on the same plane. Superior and inferior are on the same plane. You need 2 planes to determine right or left. And we're going to discover this right here with the clavicle. Are we ready? Clavicle is how your upper extremities attach to the axial skeleton. And it's not for weight bearing. It's this tiny little thing here, which is why the clavicle is the most frequently fractured bone in our body. You fall over and all your body weight goes on your arms. If it gets it, that force goes on the clavicle straight direction. Snap. It's our wishbone, by the way, clavicles. Don't look like wishbone. If we had to look like wishbones, they probably wouldn't crack so much. I mean, you just have a seat belt in your car. You rear end someone, and that thing tightens up, and your body goes forward against the strap, crack. So it's the most frequently fractured body. Now, it has a thick medial end called the sternal end, so this would be number 1. It has a flat spoon-like lateral end called the acromial end, so this would be number 2. That's on the same plane. You cannot tell right from left clavicle with just that. But yes, the sternal end is thick. Acromion is flat, like a spoon. Everybody see that? And I can put this thick one medial, the flat one lateral, and I can do this. Watch me. Medial, still medial. Lateral's still lateral, and I can't tell whether it's right or left because it's all in the same plane. Everybody got it? The thick sternal end, number one. The flat acromial end, number two. You can see that's like a spoon upside down. You can eat cereal with this end. What you can tell right from left from is this one thing right here. And that's number three, the conoid tubercle. And what I would write on the conoid tubercle, and I would use one color for this note because this is what you're going to write to determine right from left. The conoid tubercle points down, inferior. Can you see that on the picture? It's pointing down, inferior. And it is on the posterior side of the bone. So if this is a lateral view, that means this is posterior, this is anterior. It's pointing down. You can see it pointing down, but it also means this is posterior and this is anterior. And by itself, you can tell right from left clavicle because it by itself is on two planes. Everybody got it? For example, if I put it over here like this, look at me. Can everyone see this thing pointed down? By the way, if I use the clavicle on lab exam 1, it's going to be from the green box because the green box clavicle has the biggest conoid tubercles. Can you see that thing drooping down? In fact, these pictures I took of this one. If I put it over here, this is not right. Because why? It's on the anterior side. It's got to be posterior. So let me turn it to the posterior. Okay, now it's on the posterior, but look at it. Now it's pointing up. And that's not right. The only way this works is if I flip it over like this, and now it's on the posterior side pointed down. This is a right clavicle. Do you see how you need things on two planes? If you have things on two planes, you can determine right from left. And for the clavicle, all you need is the conoid tubercle. Posterior side of the bone points down. Sternal end is thick. 2, acromial end is flat. Sternal end is thick. 1, acromial end is flat. 2, but here's this guy, the conoid tubercle is pointing down. Any questions? Let's go to the scapula. This is the glenoid cavity, number 4. Next to glenoid cavity with that same color, I would write lateral. And again, if you have the articulated skeleton out, you can see why it's got to be lateral. Because it's the socket of the ball and socket shoulder joint. It's got to face lateral, and the head of the humerus has got to face medial. There are two different spikes coming out. The one that's anterior, this is a posterior view, so now this is farther back toward the anterior. That is the coracoid process, number 5. Check out the spelling. Coracoid. Go down to number 22. Look down at number 22. On the ulna, you have the coronoid process, and that's why you lose a half point for spelling. Coracoid and coronoid are very similar in spelling, only 2 letters apart. They're different things. You gotta hit the spelling. Everybody got it? All right. Right there is the acromion, number 6, and that articulates with the acromial end of the clavicle. But this right here, at 12 o'clock, that arrow, is the spine of the scapula. And with that same colored pen, I would write posterior. And that's 2 different planes. Glenoid fossa points lateral, spine is posterior. If I put the glenoid fossa lateral over here, the spine is anterior, and you can see why you can't have a spine anterior, because it would get caught in my ribs. And you wouldn't be able to do this. It's got to be smooth on the anterior side of the scapula. You can't have a spine anterior, it's gotta be posterior, away from the ribs. So if I go like this, no, that's wrong, because the spine is anterior, it's gonna get caught in my ribs, so I put it over here. Yeah, spine is posterior, glenoid cavity is lateral, this is a right scapula. So those are your two things. What I would write next to the acromion is the lateral end of the spine. The acromion is the lateral end of the spine, so if you follow the spine out toward the glenoid fossa, that's lateral. Spine, 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 ends at the acromion. Lateral end of the spine. The spine also causes two cup-shaped landmarks. The one above the cup-shaped landmark, or above the spine, is called the supraspinous fossa. That's that one. The one below the spine is the infraspinous fossa. Do those names make sense? Any questions? Everybody got these? Any of these are fair game, and this is your best friend, because I'll tell you what, in the skeletal system there is way more landmarks than this. This is the limiting list of what I can ask you. Lateral view. So if this is the left scapula, you're looking at this scapula, which means that's anterior. And that's a coracoid process. And that's posterior. So this is the spine of the scapula posterior, coracoid is anterior, and at the lateral end where it's pointed closest to the camera, since this is a lateral view, the lateral end is the acromion. That's way up there on the top left. Almost looks like a capital Y, doesn't it?
Yes.
Scapula. Okay, everybody got these four?
The bottom arrow is the number 4?
Yeah.
Okay, thank you.
Glenoid cavity. You could call it glenoid cavity or glenoid fossa, either one. Any other questions? Anterior view. So again, glenoid cavity again is the socket. Since this is anterior view, the one closest to us is the anterior coracoid process. One further away is now the acromion. And this is the smooth subscapular fossa right here. Any questions? All right, you might be asking, why are we covering the bones first? I want you to keep your place there on page 7, turn to page 16. Turn to page 16. Upper right of the page, 16. Rotator cuff, the second section. Everybody see rotator cuff? 4 muscles forming a ring of attachments around the head of the humerus. Skip the first one, teres minor, but look at these names. Supraspinatus originates from the supraspinous fossa we just covered. Infraspinatus originates from the infraspinous fossa. Subscapularis originates from here. Subscapularis, from the subscapular fossa. Everybody got it? So a lot of the names of the muscles don't make sense until we learn the bones. That's why we're learning the bones first. Any questions about that? Okay, go back to page 7. This is how the ball and socket shoulder joint come together. You can see the head of the humerus has to be medial. In fact, next to where it says head, number 13, from that same colored pen, I would write medial. What's that?
Where should we write medial? 13.
Number 13. This is the head going medial. If this glenoid cavity is going lateral, this head is pointing medial to meet it. Everybody see that?
Mm-hmm.
The head of the humerus is medial. This is from an anterior superior view, looking down on the shoulder joint. That's what was actually taken from this guy. Looking down on the shoulder. But from the anterior side, that's why the coracoid process is staring right at you. because it's still anterior. Here's the head of the humerus. By the way, if multiple bones have head, you have to say head of the humerus. Okay, since nobody wrote that down, I'll say it again. If multiple bones have head, you have to say head of the bone. This is head of the humerus. So we've done these two arrows on the bottom, the ones on top. This one on the right here is the acromion, and it articulates with the acromial and the clavicle. That's this one here going off at 10 o'clock. Everybody got these four?
Can you do the bottom two?
What's that?
Can you do the bottom two more?
Coracoid process, head of the humerus. Okay. We're ready to go to humerus. Shall we go? Are we ready? Okay. This is the greater tubercle. This is the lesser tubercle. It's smaller. Here's the head of the humerus. You should have wrote medial. Greater tubercle is lateral. That's the same thing. That's not going to help you. What's going to help you is this guy. Lesser tubercle is anterior. So with that same color ink, lesser tubercle, right anterior. Head of the humerus is medial. There's your two planes. About mid-diaphysis on the lateral side is the deltoid tuberosity. And I use this opportunity to cover for you why it is we got all these bumps. If we had our lab exam 1 on fetal bones or neonatal bones, it would be really sad, number 1. And number 2, it would be really easy because these bones hardly have any bumps. A lot of the bones genetically are very simple. What happens is once you're out in gravity, once you start crawling around and walking and running around, now all of a sudden these muscles are pulling on bones. You following me? Are you guys bored with this? Because I could just do blanks. When you pull on bone, you activate the bone forming cells called osteoblasts, and it lays down a bone. And when the little kid is doing this enough times, the deltoids are pulling on the lateral diaphysis. And after enough times, you got a bump from the deltoid pulling on that spot. That's why it's called the deltoid tuberosity. Everybody got it? All right, this is on the distal end of the humerus, and it says posterior view. So this is one of the structures where the name makes sense. This right here is a large cup called the olecranon fossa. What's number 20? Olecranon. Those names make sense. Because when your elbow is straight, when your arm is straight, the olecranon of the ulna is sitting in this cup. Olecranon fossa. It's named for what sits in it when your elbow is straight. Everybody got it? Here's the plus minus. That is the trochlea. This is the right. So that's medial. Turn to page 8 near the bottom. Look near the last thing listed under femur and the first thing listed under tibia. What does it say? Lateral medial condyles, okay? On those bones, the condyles aren't named, so we just call it medial or lateral condyle. Everybody got it? On the humerus, everybody look at me, because I'm trying to make this make sense. The condyles are named. And the trochlea is the medial condyle of the humerus. But you can't get a full point for calling it medial condyle of the humerus. You gotta call it the trochlea. Everybody got it? So condyle sticks out, so that's the plus, but if you notice there's a concave groove in it, that's why it's a plus minus. Everybody's got that? Since it is a condyle, the bump next to the condyles are called epicondyles. The bump next to the trochlea, since it's the medial condyle, is called epicondyle. Everybody got it? All right. This is distal humerus, but now it's the anterior view, so you flipped it over. And here we have the coronoid fossa. What is that, 16? What is 22? Coronoid process. And when your elbow's completely bent, that process is sitting in this cup. So it's kind of like the equivalent of the olecranon and the olecranon fossa. This is the coronoid process and the coronoid fossa. Everybody got it? These names make sense. Take advantage of it. Because when you're studying for lab exam 1, your brain's going to be thinking this is too much. Well, how do you make it not so too much? By utilizing the names that make sense. Boom, you go like that. And you can save your brain for the names that don't make sense. Does that make sense? All right, here's the two condyles. This is the medial one called the trochlea. Again, it's got a groove in it. Here's a lateral condyle we call the capitulum. This is the capitulum, but these are the two condyles. So these two bumps are epicondyles, and you just got to call them an epicondyle. You don't have to call it medial epicondyle or lateral epicondyle, even though your textbook does. Everybody got these? Anybody need it clarified? This is the medial epicondyle, this is the lateral epicondyle. You just have to call it epicondyle because that's how it's listed on page 7.
What's on the very bottom?
These are the condyles, trochlea, capitulum. This is the medial condyle, this is the lateral condyle. On the femur and the tibia, that's all you call it. But on the humerus, they're named, so you have to call this trochlea and capitulum. They are the condyles. Everybody got it? Everybody know what itis means? Huh?
Inflammation.
It means inflammation of. Laryngitis, inflammation of your voice box. Bronchitis, inflammation of bronchioles. Everybody got it? Can anybody tell me the common name for medial epicondylitis? Inflammation of this bump?
Bursitis.
You guys haven't heard of tennis elbow?
Oh, I said bursitis.
How about this one? Lateral epicondylitis.
Oh, no.
Anybody heard of golfer's elbow? Golfer's elbow is this one. Tennis elbow is this one. All right, let's move on. Okay, this is showing you the olecranon of the ulna, number 20, sitting in the olecranon fossa when your elbow's straight. Two names that make sense. And this is showing you the coronoid process of the ulna, because we're going to have coronoid process of the mandible later. 22, when the elbow is bent all the way, goes into 16, coronoid fossa. This is also showing you, all right, let me ask you this. This is why you got to pay attention, because you guys got a long ways to go. How many bones are in your arm? This is showing you the elbow. How many bones are in your arm?
6.
So you guys got a long way to go. There's one. Brachium is the arm, and it goes from shoulder to elbow. You only have the humerus. That's all in your arm. This is not your arm. This is your forearm. In medical terms, it's antebrachium, forearm, and there's 2 bones. Everybody got it? And it's the radius and ulna. These are simple things that everyone should know, even patients. So if you're gonna be a healthcare provider, if you're gonna take the NCLEX, you better know this. Okay, so the forearm, you have the radius and ulna. What you want to write down on page 7 is the radius goes to the thumb. Radius goes to the thumb. Just keep that in mind. It's the simplest way to remember it. Radius goes to the thumb in anatomical position, which is the lateral forearm bone. Radius, because it's going to the thumb. Everybody got it? In anatomic position, radius is lateral, so that's what you should say. Radius goes to the thumb, so it's lateral. From this view here, you can see that the ulna articulates with the trochlea, the medial condyle, and the radius, this is the head of the radius, articulates with the capitulum. That's what I wanted to show with this picture. And it's a big picture, how does everything fit together picture. Ulna goes to the trochlea, radius goes to the capitulum.
Can you go back just to the bottom right arrow? I'm sorry, I missed that one.
This one?
That one, yes, please.
Head of the radius.
Thank you.
Both ulna and radius have styloid processes, so you have to say styloid process of the ulna, styloid process of the radius.
Ulna is on top.
Yep. You know how you can tell that's the ulna? It's got a U on it. See the big U, it's an ulna. See this head of the radius, how it's a disc? It's very circular. Everybody see that? Well, a circle has a circumference, a diameter, and a radius. Look at the heads of these bones, and you can see the U with the disc with the radius. All right, on the ulna, let's go over this. Number 20, olecranon, right there. It's actually in anatomic position more proximal than anything else. The U that you can recognize as the ulna is the trochlear notch. That's the long arrow. It articulates with what? The trochlea. Those names make sense. And that is the coronoid process. Comes to a point. All right, with that color pen, I would write next to trochlear notch, anterior. Trochlear notch opens to the anterior, because I don't know anybody's elbows that bend to the posterior. Bends to the anterior. And then this is the radial notch. And with that color pen, I would write lateral, because the radius is lateral. All right. You guys gonna let the points go past your ears? It's up to you. I mean, I already passed this once. Stations 1 and 2 are gonna be over here. They're gonna be both of the microscopic bone structures. Both of those models. 3 and 4 are going to be long bone structures. Diaphysis, epiphysis, epiphyseal line, spongy bone, compact bone, whatever. Starting on station 5, 6, 7, 8, and 9, and on some versions, 10, are just going to be an appendicular bone without any pins. Follow me? The models and bones with pins you cannot touch. These guys, 5 through 9 or 10, you can. And all big green letters and say, yeah, go ahead and pick this one up. As soon as you get past the ones where we get return the pins, it'll say, do not pick this, don't touch this. Okay? So, you're gonna pick it up, and the A question for these stations is going to be, what bone is this from which side of the body? That's how I'm gonna test you, do you know right from left? This is where you've gotta apply the two different planes. Are we clear? So, you got an ulna. This is one of the harder ones to do, right or left. But you know it goes on your forearm on the pinky side. Radius goes to the thumb, correct? You know the trochlear notch opens up to the anterior, so you put it on this side, and then you sight this thing down like a rifle. And you're gonna see this circular cutout where I'm putting my thumb. And why is there a circular cutout? Because the disc-like head of the ulna the radius goes right in there. Look where these bones are tapping. Now look at this one in this hand. And hopefully you can see it back there. Can you see a circular cutout in this bone for this disc-like head?
Yes.
Can you see that? If not, try to see it later. But right where the bones I'm tapping, the disc-like head of the radius is tapping the radial notch. And when you put this bone on your forearm and sight it down like a rifle, you can see that circular notch. Everybody get it? Can you see it? Right where they're touching. On this bone, there's a circular cutout, and it is. It's almost like someone put out a protractor or something and drew a circle. It is a circular cutout for this disc-like head. You following me? Then you got to remember that this is the medial bone. So if you put it over here, trochlear notch anterior, side like, oh, you see this, here's the radial notch, well, it's medial. There's no bone medial to this. This is the medial bone. You got this on the wrong arm. You got to put it over here. Again, trochlear notch anterior, and now you can see the radial notch is lateral, like the color ink you just wrote next to radial notch. It's lateral because it's facing where the radius is. Because the radius is the lateral bone. This is a right ulna. Do you see how you do ulnas? Right or left? If you are passively listening, you do not know what I just said. Now you're either going to ask me later, or you're going to get it wrong. Those points went past your ears. Okay. The styloid process for the ulna doesn't really help because it's posterior. But it will help you for the radius. And this is why. Here's the disc-like head of the radius, even though on this picture, this bone is actually chipped a little bit. But here is the radial tuberosity, and you want to write anterior in that color ink. Radial tuberosity is anterior. It's where the biceps brachii inserts. That's what forms it. And of course, it's pulling from the anterior. So it's going to be anterior. Everybody got it? When we get to doing lab exam 2 material on the muscles and the actions, there is a slight medial inclination to this radial tuberosity. Don't worry about it now. I will mention it again later when I cover muscles, and especially movements. But it's mostly anterior. It just has a slight medial inclination, but it's anterior. Same thing here, head of the radius on top, radial tuberosity on the bottom. It is close to the head. Same thing up there, head of the radius, radial tuberosity. And here's the styloid process of the radius, and this one will help you on the radius. You want to write lateral. So radial tuberosity anterior, styloid process of the radius lateral, 2 planes. Any questions? There's a styloid process there again, lateral. All right. Let's cover this. basis in blue, right?
Yes.
Everyone knows what those symbols mean that you wrote on page 15? All right. Next to, we're on the top of page 8. You should write that you don't need to worry about right or left for the carpal, metacarpal, and phalanges. And the reason why is if I ask any questions here, it's going to be a right hand anterior view. Okay, just so that you know how the body works. Carpal bones are in the wrist. Metacarpal bones are in your palm. And phalanges are out in the digits. Carpal bones are in the wrist. Metacarpal bones are in the palm. Phalanges are in the digits. And on lab exam 1, it'll always be right hand anterior view. I'm gonna make it that straightforward. You need to know that your digits have Roman numerals. Your thumb is number 1. Your pinky's number 5. Some of you use number 3 on the freeway. Okay, you have 8 carpal bones. You only have 7 tarsal bones because 2 of them fused, but you have 8 carpal bones. This is also showing you how I used to draw a lot of sketches in anatomy, and they're not necessarily anatomically correct. They're showing things that my brain can identify with. First of all, out of the 8, there are 4 proximal bones, 4 distal bones. So if this is right hand anterior view, what you're looking at is this. What you're looking at is what is on the screen. And up on top, those arrows, the left one is the radius, the right one is the ulna. Everybody got it? Right hand anterior view. The 4 proximal carpal bones are scaphoid, lunate, triangular, and pisiform. And I drew it like that because the pisiform actually sits on top of the triangular. Scaphoid, lunate, triangular, and pisiform. This pisiform fell off because the fishing wire was too loose. But it actually should be sitting on top of the triangular. It's helping to form the medial wall of the carpal tunnel. Have you guys heard of carpal tunnel?
Mhm.
Well, these are carpal bones. And that's why I drew it like this. Pisiform sits on top of, from an anterior view, the triangular. What's easier to spell, triangular or trichetrum?
Yeah.
So, yeah. You're not gonna impress me by spelling trichetrum. I'll be thinking, well, especially if you misspell it, you just lost that point. Okay, everybody got this? It's just right in a row, from lateral to medial, scaphoid, lunate, triangular, pisiform. Everybody got it? Then you have trapezium, and this was sitting on top of it, trapezoid. Capitate, the reason why I drew the C like that is because capitate is the largest carpal bone. And then hamate. The reason why I wrote it like that is because hamate has a hook on it as it's forming with the pisiform, the medial wall of the carpal tunnel. And you could use a mnemonic for this. Some lovers try positions that they can't handle.
Yes.
The problem with mnemonics is, especially if you have a lot of the same letters, there's a lot of T's, triangular, trapezium, trapezoid. But it helps you just go in order, you know, you're just going from lateral to medial, first do the proximal ones, then do the distal ones. Everybody got it? If I pin this, what would your answer be on lab exam 1? Knowing these numbers. This would be metacarpal Roman numeral 5. Let's put it right next to it. Metacarpal Roman numeral 5, going to the pinky. Again, metacarpals are on the palms. Phalanges are in your digits, and it's intuitive, people. You have to name them. But it's easy. Just look at your hand. How many phalanges do you think you have in your thumb? 2. How many phalanges do you have in the other fingers? 3. That's what it says there, don't it? You do have to know that the thumb is called the pollex. Let's turn to page 16 again. And on the bottom left, you have pollicis muscles moving the thumb, because the thumb is the pollex. Everybody got it? Okay. Well, it's intuitive, so you have to name them. It's really easy. This is proximal and distal phalanges of Roman numeral 1. But the rest of the fingers, it's proximal, middle, and distal phalanges of Roman numeral 2. Proximal, middle, distal, Roman numeral 3. Proximal, middle, distal phalanges, Roman numeral 4, and on and on and on. Everybody got it? Everybody know how to do that? Any questions? Don't have to worry about right or left for the carpal, metacarpals, or phalanges. It will always be right hand anterior view. Any questions? Okay, let's go ahead and take a break at 3 o'clock on that clock. I'm going to continue on with the lower